Hello everyone, welcome back to this video tutorial series on D04 microcontroller based system design lab course. In this session, we are going to interface an LED with PIC18f4520. Now in this schematic you can able to see there are 8 LEDs which are connected to the port B of PIC18f4520 microcontroller. Now if you want to configure this particular port or a pin as an output or an input, you need to know what are the registers are available for this PIC18f4520 microcontroller. Now if you want to write something onto this, or if you want to read something from this pin or a port, you need to know the registers. So there are 3 registers are available in PIC18f4520 which are related to IO ports. The first register is TRIS register, which is used to configure the data direction of port. So by using this particular registers, you can able to configure whether the pin is input or output. Now if you want to configure the particular port for output, you need to write TRIS and the name of the port. So in PIC18f4520 we are having 5 ports A, B, C, D, E, and in this schematic we have connected LEDs to the port B. So we are going to use TRIS B equals to, and we are going to write 0. So if you are writing 0 on this particular port, it means that the port B is configured as output. Or if you write TRIS B equals to 1, it means that this port is configured as input. Now the second register, which is port register, which is used to read the level on GPIO pin or whole port. So if you want to read the status of the pin or a port, you can make use of this port register. So for example, let's say if you want to read the status of pin 1 of port C, so you can able to make use of this port register. Now the third register is called as LAT register, which is used to write something onto the port or a pin. So we are going to use these three different registers for configuring our IO port, for writing something onto the port, and for detecting the status of a pin or a port. So we will just configure the port B as a output. So for that we are going to use TRIS as a register and the name of the port, which is port B, equals to, we are going to write 0x00, means whole port which is of 8 bit wide can be configured as output. Now we need to write something onto the port, the whole port. At that time we need to use this LAT register. So let's say we are writing over here 00. So let's say we will write 0x00. So all LEDs will be turned off. So let's say LED off. And if you want to turn on the LED, you need to write LATB equals to 0xFF, means all 8 pins are 1111. So over here LEDs will turn on. So just to blink the LED, we will use one super loop, which is while 1. So while 1, and inside that we are going to write this turn on and turn on option. So after turning off the LED, we will just add one delay. so that LED will be turned on or off for some time, and after that it will be turned on, and again there will be a delay, so that LED will be turned on for some time, LED will be turned off for some time. So we are going to use one built-in function which is a delay underscore millisecond or delay underscore microsecond. So if you want to use this particular function, you need to define the frequency of your microcontroller. So for that you need to use macros. So just define the macros by using hash define keyword. So we are going to hash define, and there is a macro for defining this frequency is underscore xtal underscore freq. As we know, this particular microcontroller will works up to 40 megahertz. So we will just define that. So 40 and 6 times 0. So this is the 40 megahertz of frequency. And now we will use the delay function. So double underscore delay underscore and millisecond ms, and inside that you need to provide the value for this function. So let's say it is 1000 millisecond. So LED will be turned off and it will wait for 1000 millisecond. Again LED will be turned on, and after that it will be turned on for, let's say, 1000 millisecond. So this way you can able to just turn on and turn off the particular port using LAT register. While by using TRIS registers you can able to configure the particular port or a pin as a output. So now we have just written the code for this blinking the LED. Now we will just compile it. So you need to click on this build main project. After clicking, you can able to see that the code has been compiled, and you can able to see over here the code is successfully compiled, and the hex file related to this project is stored at this particular location. So now we go back to our schematic, and if you double click onto this microcontroller chip, you will get the option for program file. So just go to over here and see where your hex file is stored. So the hex file is stored at users does mplabx project blinky distribution default production and blinky dot production dot hex. So just select this file, open, and provide the frequency which is 40 megahertz, and just click OK, and you can able to see, if I run it, you can able to see the blinking of LED. So this way you can able to interface LEDs with your microcontroller. So in the next section we are going to see how you can able to check the status of a pin or a port, and by using that we are going to turn on these LEDs based on the status of input signal.